At noon, the sun looked like a dirty coin. A farming family stood outside their wooden house staring upward. The sky was bright enough to see, but the light felt weak and gray. The sun had lost its sharp glare. It hung behind a pale veil, almost like the moon had accidentally been assigned the day shift. At first, the village probably blamed clouds. Strange weather came and went. Someone may have confidently announced that everything would look normal by morning, because every village has at least one man whose main skill is being wrong with confidence. Morning came. The sun was still dim. Days passed, then weeks. Shadows stayed faint. The ground received daylight without much warmth. People could look toward the sun without immediately turning away, which is not a useful improvement when your entire food supply depends on that light. This was the year 536, and ordinary farming communities across parts of the Northern Hemisphere were about to learn how quickly the world could stop behaving normally. They did not know that future historians would call this one of the darkest periods in human history. They only knew that spring felt cold, the sky looked wrong, and the plants were growing too slowly. Fruit trees blossomed late. Small green fruits appeared but refused to mature. Grapes remained hard and sour. A winemaker could crush them, wait patiently, taste the result, and discover that the grapes had somehow produced disappointment in liquid form. Written accounts from the period describe weak, eclipse-like sunlight. One chronicler later wrote that the dimness continued for many months and that fruit failed to ripen. The details varied by region, but the basic problem was the same. The sun was visible. Its warmth was not. For farmers, that was more than strange. Their lives depended on predictable seasons. Seeds went into softened ground. Plants grew through warm months. Grain ripened before autumn rain and winter frost. That year, the calendar said summer, but the weather had apparently stopped checking the calendar. Cold conditions continued into months that should have been warm. In some regions, frost struck during the growing season. Records from East Asia describe severe summer cold, including reports of snow falling when farmers should have been watching crops ripen. Imagine waking up to a white field in the middle of summer. Children might have rushed outside, delighted by the surprise. Adults would have understood immediately that this was not the fun kind of weather mistake. Frost could kill blossoms, damage young plants, and ruin grain before harvest. A small temperature drop sounds harmless when it appears as a number. 1 or 2 degrees does not seem dramatic on a household thermostat. Agriculture is less relaxed about it. A short cold spell can delay planting, shorten the growing season, and expose crops to frost before they are ready. The first harvest was poor. The farming family gathered what grain they could. The bundles were thin. Storage jars that should have been full remained partly empty. Every missing sack meant bread that would not exist later. People stretched supplies. Loaves became smaller. Porridge became thinner. Wild plants and stored roots became more important. Families looked inside grain jars far too often, as though the food might become nervous and reproduce. One failed harvest was dangerous, but many communities had ways to survive a bad year. They stored grain, borrowed from neighbors, and traded with places where the weather had been kinder. The problem was that reports of strange conditions came from far beyond one valley. In China, chroniclers described yellow material falling from the sky. People could collect it by hand. They called it dust, though its exact nature remains uncertain. To anyone standing beneath it, the scientific label probably mattered less than the fact that the sky was now dropping suspicious powder onto the crops. A farmer holding out a bowl for rain and receiving yellow dust instead could reasonably conclude that the weather had become personally hostile. Cold summers damaged harvests in parts of Asia. Food shortages appeared across parts of Europe. The crisis was not identical everywhere, but it covered enough territory that ordinary trade could not easily solve it. A nearby town might have grain, but everyone else wanted it too. Merchants could move food from one place to another. They could not move food from a field where it had never grown. The next planting season brought a little hope. The sky seemed brighter in some places. Seeds went into the ground. Green shoots appeared. The farming family may have believed the strange year was finally ending. Then the cold returned. Modern evidence suggests that the crisis did not come from one brief event followed by a clean recovery. Additional major volcanic eruptions occurred during the following years. Each one may have sent more particles into the atmosphere and extended the cooling. The world did not simply suffer one terrible summer. The disaster kept renewing its subscription. Another weak harvest meant fewer reserves. Families searched farther for food. Some left their villages for towns or regions rumored to be doing better. Cities received more hungry newcomers while depending on rural areas that were producing less grain. The pale sky was no longer just a weather problem. It had become a food problem, a trade problem, and a movement problem. Centuries passed before anyone could see the full cause. Modern scientists found clues in glaciers. Year after year, snow had fallen, compressed, and turned into layers of ice. Those layers trapped tiny pieces of the atmosphere. When researchers drill out a long ice core, they are pulling up a frozen timeline. Most sections look ordinary. Then, around the middle of the 6th century, the chemistry changes. The ice contains sulfur and volcanic material from a massive eruption. The strange sky had left fingerprints sealed beneath centuries of snow. Trees kept a second record. Each year, a tree adds a ring. Warm, favorable seasons usually allow more growth. Cold and stressful seasons create narrow rings. Trees that lived through the 530s and 540s show an abrupt slowdown. The people left only scattered descriptions. The trees quietly kept better notes. The most likely explanation begins with an enormous volcanic eruption. Scientists still debate exactly which volcano caused the first event. The eruption may have happened far from the farming communities that suffered its effects. What mattered was what reached the upper atmosphere. Large eruptions can send sulfur-rich gases above ordinary weather systems. There, they form tiny particles that reflect some sunlight back into space. The sky does not need to turn completely black. It only needs to block enough energy to cool large regions below. That is why the sun could remain visible while appearing pale and weak. It was shining through an atmospheric veil. Many people affected by the disaster probably never heard the eruption. They saw no lava. They felt no earthquake. A volcano thousands of miles away simply reached across the planet and ruined their growing season. It was history's least convenient long-distance delivery. The later eruptions made recovery harder. Just as crops and temperatures might have begun returning toward normal, more material entered the atmosphere. This helped begin a longer cold period that lasted well beyond the original year. By the early 540s, many communities had already endured repeated harvest failures, food shortages, disrupted trade, and years of uncertainty. Then plague arrived. The disease spread along major routes and through crowded cities. People at the time did not understand bacteria or the complicated ways infections move between animals and humans. They only saw households becoming sick, workers disappearing, and normal life slowing down. The climate disaster did not create the plague bacterium. The volcano did not manufacture the disease. Cold air did not turn famine into plague. They were separate events. The connection was indirect. Years of weak harvests had placed many communities under stress. Hunger reduced resilience. Migration moved people across long distances. Trade continued because cities still needed food, and the same routes that carried grain and goods could also help disease travel. Plague entered a world with fewer reserves. A healthy town might absorb one crisis. Stored food could cover a temporary shortage. Neighbors could replace missing workers. Local systems could keep operating. After years of poor harvests, those safety margins were smaller. When illness removed farmers, merchants, mill workers, and animal handlers, food production and distribution became even more difficult. The disaster chain had closed into a loop. The pale sun lowered temperatures. Cold damaged crops. Failed harvests spread hunger. Additional eruptions delayed recovery. Hunger and movement strained communities. Then, plague placed a new burden on a world already running on emergency supplies. No one living through it could see the entire sequence. The farming family saw only pieces. A weak sun, sour grapes, frozen plants, thin harvests, travelers on the road, and towns becoming quieter. Each event may have looked like a separate piece of bad luck. Modern science connected them using old chronicles, volcanic traces in ice, and narrow tree rings. Together, they reveal something larger than one terrible season. The year 536 was not simply a bad year. It was the beginning of a system failure. The people who looked up at that pale sun could not see the volcano behind it. They did not know more eruptions were coming or that plague would arrive years later. They only knew the daylight felt wrong.